कर दिया था हमने। वर्क एनर्जी थ्योरम किया था। ये नहीं किया था, ये किया था। होगा। Basically, this guy tells us that summation of work done on any system is equal to change in kinetic energy. So let me be very specific. For 1 point particle, summation of work done by all forces acting on particle is equal to the change in kinetic energy of that particle. Okay? For a system of point particles which are connected to each other by strings, surfaces, springs, summation of work done by all summation of work done by all forces acting on particle 1 plus summation of work done by all forces acting on particle 2 so on is equal to change in kinetic energy of particle 1 plus change in kinetic energy of particle 2 so on. Even friction force, yes. Even friction force, yes. Okay. Please write this down. Take a screenshot, write this down. का प्रूफ मैंने लास्ट क्लास में कराया। लिख लिया, आगे बढ़ो। ओके, तो एप्लीकेशन ऑफ द वर्क एनर्जी थ्योरम। मैंने एक क्वेश्चन किया था ना स्प्रिंग वाला, इफ आई रिमेम्बर करेक्टली, है ना? योर टर्न। ब्लॉक ऑफ mass m is dropped on a spring initially at its natural length as shown. Find the maximum compression of spring. No, you have not done this. Try this out. हाँ, वो हमने उल्टा किया था। उसमें क्या किया था कि block was attached to a spring and we simply let it go. Here the block is falling on a spring. और ना, कभी हम पोटेंशियल एनर्जी की बात नहीं कर रहे हैं, ठीक है? काफी देर तक करेंगे भी नहीं। स्प्रिंग रुक जा रहा है, मतलब क्या हुआ? नहीं, गलत है। उसके बाद क्या होएगा, बाउंस बैक होएगा नहीं होएगा, उससे हमें कोई मतलब बोला भाई, बहुत बढ़िया बात। यस, नहीं आर्यन गलत आंसर है, वेरी गुड बात। अभी लोग जल्दी से करो। नहीं हो रहा है, चल ठीक है। सो प्लीज अच्छा, टाइप नहीं करना, टाइप करेगा मतलब तो टाइप में। अच्छा, सब सही है, आंसर सही है। What is the first step? Okay, the first step is always to recognize whether you are dealing with this situation or you are dealing with this situation. So here I can be absolutely sure that I am dealing with the first situation because there is only one particle. अब वो जिस पैन पे गिर रहा है, अगर मैं बोलता नहीं उसका भी मास है, तब थोड़ा लोचा हो जाता है। Now, once you have decided that yes, there is only one particle in the system or there are many particles in the system, what you need to do is you need to figure out the initial configuration of the system and the final configuration of the system, right? So the initial configuration of the system is given, and finally what is going to happen is that this spring will be compressed and the pan will be here and the block will be here. So if this is the initial location of the block, then this must be the final location of the block. Then you need to know the path which has been taken by the particle. In this case, this is the path that has been taken by the particle. Once you have figured all these things out, the real trick is to figure out the initial and final configuration of the system. Once you have figured everything out, now you are in a position to apply the work energy theorem. Remember, मैंने आपको बहुत ही स्पेसिफिकली और बार बार बोला है कि लाइन इंटीग्रल में जो प्रीरिक्विजिट्स होते हैं वो हमें फोर्स मालूम होना चाहिए, हमें इनिशियल एंड फाइनल पॉइंट्स मालूम होने चाहिए और हमें पाथ मालूम होना चाहिए. Although we are not going to carry out the line integral here, but wherever the quantity called work is involved, there is an underlying principle कि हाँ भाई यहाँ line integral तो carry out होएगा. Although physically आप करेंगे नहीं, but होना तो है background में. So this means that you need to have these prerequisites at hand if you want to solve the problem. Okay. So once I know the initial and final position, once I know the path, once I know the forces that are acting on the object, in this case, for a part of the path, only gravitational force acts, and then for the remainder of the path, gravitational force and spring force, they act together on this particle. Once I have figured out all these pieces of information, now I can, good Aryan, yes. Now I can work out, I can apply the work energy theorem. Okay, how to do this? Summation of work will be equal to work done by Earth plus work done by spring. Work done by Earth will be equal to plus, because it is going down, mass of the system G, and the height, vertical distance between the initial and final points, which is h plus x, plus work done by spring is half k into initial elongation or compression square minus final elongation or compression square. The initial kinetic energy of the object is 0. Final kinetic energy of the object is also 0, because उसको रेस्ट से रिलीज किया है तो इनिशियल काइनेटिक एनर्जी 0 है. वो फाइनली रेस्ट पे आएगा, इसलिए उसकी फाइनल काइनेटिक एनर्जी भी 0 होनी चाहिए. Okay? That is where you get the maximum compression. So I get mgh plus mgx minus half kx square is equal to 0. X square minus 2mg by kx minus 2mgh by k is equal to 0. Right? The solution to this quadratic equation must be, so x is equal to minus b, which will be 2mg by k, plus minus, right? So if I take plus, I'll get the maximum compression. If I take minus, then I will not get the maximum. We are looking out for maximum compression, right? Plus minus b square 4m square g square by k square, right? Minus 4ac. Minus का plus हो जाएगा क्योंकि यहाँ पे minus है. I'll get 8 mgh by k and whole divided by 2. Oops. Whole divided by 2. So this becomes mg by k plus root of Now you know what to do, right? M square G square by K square plus 2mgh. This is the maximum compression. This is the maximum compression. आया समझ में सबको ये? I will change the slide. Please take a screenshot. Please take a screenshot. Common velocity मतलब दोनों की same velocity. हाँ हाँ So now we are dealing with this situation. And to deal with this situation, what you need to do is you need to figure out the initial and final configuration. To do that, I will draw this here. So this is the initial configuration of the system. One block is moving, the other block is not moving. It is attached to a spring constant K. And we have a final configuration of the system where we have block 1, spring, block 2, and both of them are now moving with a velocity of v0 by 3. Right? Now, why is there a need for me to give a common velocity? What is the importance of common velocity? Right? ये मुझसे पूछा जा रहा था that why what is the rationale of giving the common velocity? Just like हाँ फाइनल की वैल्यू है बट उसका एक रैशनल भी है. Just like when you have a single spring and a block like so. Okay? You have a single spring and a block like so. Then for the condition of maximum compression or maximum elongation, what happens is that we see that look, this end of the spring is fixed. The velocity of this end of the spring is 0. Therefore, for maximum compression or maximum elongation to occur, the velocity of this end of the spring must also become 0. So basically, if I have a spring and if I have the, or if I consider the two ends of the spring, if the velocities of these two ends are separate, then something is going to happen to the length. So if V1 is greater than V2, if V2 is greater than V1, if V1 is equal to V2, then what is happening to the length of the spring? Well, if V1 is greater than V2, this means that this end is moving faster than this end, right? And therefore the length of the spring is contracting. ठीक है ना? अब ये elongated है या compressed है ये मैं नहीं बता सकता, लेकिन मैं ये बोल सकता हूँ कि अगर V1 greater than V2 maintain किया जाएगा, at some point of time then compression will occur, because maybe initially the spring was elongated, to begin with it was elongated. If If it was elongated to begin with and V1 is greater than V2, then the spring will be elongated still, but its elongation will go down. It will keep on going down until it reaches its natural length, and thereafter the spring will get compressed. Okay, if V1 is greater than V2. What if V2 is greater than V1? What if V2 is greater than V1? Well, this means that this end of the spring is moving faster to the right as compared to this guy. So this means that the length is increasing, right? Whether the spring is elongated or compressed, that I don't know. But what I do know is that if I allow this for an extended period of time, then at some point elongation will start. Because if the spring was compressed to begin with and V2 is greater than V1, then as the right end moves further, as the length of the spring increases, the compression of the spring will decrease. Okay, it will keep on decreasing until there comes a point when the spring will be at its natural length. And if we allow V2 to be greater than V1, still the spring will then start to elongate. If the spring is originally at its natural length and V1 is greater than V2, then I have no fear or no problem in saying that compression will occur. If V2 is greater than V1 and initially the spring is at its natural length, then there is no confusion about the fact that elongation will occur. Okay? And if V1 is equal to V2, if V1 is equal to V2, then the length of spring does not change. Okay? So this is the condition. This is the condition for maximum elongation or compression. So in this case, no problems. मिडिल ऑफ स्प्रिंग में कहां से तरुण मास ले आएगा? तो फिर दो स्प्रिंग हो जाएगी ना, एक ऊपर वाली एक नीचे वाली. So in this question there is no problem. ये वाले एंड का वेलोसिटी जीरो है, ये वाले एंड का वेलोसिटी भी जीरो होना चाहिए मैक्सिमम कंप्रेशन. सिमिलरली मैक्सिमम कंप्रेशन के लिए अगर ये वाले एंड का वेलोसिटी v है तो ये वाले एंड का वेलोसिटी भी v होना चाहिए. Okay? Now you may choose to remember this, okay, or you may choose to understand this. Maximum compression or maximum elongation by definition implies that the graph of elongation is going to go like this, or compression graph is going to go like this. ये रहा maximum elongation का graph, maximum elongation का point. मैक्सिमा में क्या होता है? मैक्सिमा का क्या डेफिनेशन होता है? एक तो डेफिनेशन होता है दैट स्लोप इज इक्वल टू जीरो. लेकिन स्लोप इज इक्वल टू जीरो का मतलब क्या होता है? स्लोप इज इक्वल टू जीरो का मतलब होता है दैट द फंक्शन इज नॉट चेंजिंग. इफ आई टेल यू लुक आई हैव अ फंक्शन जिसका स्लोप जीरो, इसका मतलब कि वो फंक्शन चेंज नहीं होता, राइट? ठीक है ना? उसी तरीके से मैक्सिमम कंप्रेशन या मैक्सिमम इलोंगेशन वो पॉइंट होएगा जहां पे दोनों एंड की वेलोसिटी चेंज नहीं हो रही होगी, सेम होएगी। Either ways, same velocity implies maximum summation of work। यहाँ पे तो केवल स्प्रिंग वर्क कर रहा है। Now there is another purpose for which I gave you this question. In this, I have written work done by all forces acting on particle 1 plus work done by all forces acting on particle 2, and so on and so on and so on. Now if you come here, then you may say that work done by spring on particle 1 and work done by spring on particle 2, ये दो चीजें ऐड करनी है। Okay, but for a spring, and I will prove this later on, अभी नहीं प्रूव करूंगा, बाद में प्रूव करूंगा, नेक्स्ट चैप्टर में इनफैक्ट प्रूव करूंगा। For a spring, if the spring is connected to two blocks on its two ends, okay? If the spring is connected to two blocks on two ends, यहाँ पे कोई प्रॉब्लम नहीं, यहाँ पे स्प्रिंग का एक एंड फिक्स्ड है, फ्लोर से कनेक्टेड है, तो it is easily understandable that whatever work is being done by the spring is being done on this guy. लेकिन यहाँ पे तो दो ब्लॉक्स, so the question must arise in your mind, right? It absolutely must arise in your mind that work done by spring is defined half k xi square minus xf square. But is this work done on both particles if the spring is connected to two particles at its two ends? Or is this the total work done by the spring on both the particles which are connected to its two ends? The answer is that work done, जो expression मैंने बताया है आपको, right? That is work done by the spring on both the particles. So work done by spring is not calculated individually for both particles if two particles are connected to a spring. Let me write this here. If two particles are connected to the same spring, then work done by spring is equal to half k xi square minus xf square is the work done by spring on both particles. Okay, so please don't double it. So I get half k xi square, which is 0, minus x. Initial kinetic energy of 1, half mv naught square. Final kinetic energy of 1, half mv naught by 3 whole square. Initial no, you are so the question is, but the spring doesn't change its length with common velocity. Why not spring force on the system is equal to 0? पहली चीज, spring force depends on the instantaneous elongation or compression. If at this point, when the velocities of the two objects have become same, if at this point the spring is at its natural length, then the spring force will be 0. If the spring is compressed or elongated at this point, spring force will not be 0. Okay? But if I can guess where this question is coming from, the source of this doubt is essentially the difference between Newton's laws of motion and work energy theorem. The work energy theorem operates between two configurations in time. That means that I will apply work energy theorem on the Earth-Sun system, for example, in the duration of 1 year or in the duration of 6 months, suppose. तो 6 months में पहले अर्थ सन सिस्टम का क्या कॉन्फ़िगरेशन था और 6 months के बाद अर्थ सन का क्या कॉन्फ़िगरेशन, that will decide on which direction the work energy theorem, or that will decide how the work energy theorem will be applied. Newton's laws of motion are applied at a single instant. We don't ask कि वो ब्लॉक ऊपर से नीचे आ गया क्या, अब मैं अप्लाई करूं क्या, F इज इक्वल टू ma, नहीं. ये ब्लॉक अपने मोशन में किसी भी मोमेंट पे मैं अप्लाई कर सकता हूं. F is equal to m. Now the problem is नहीं अभी सुनो, अभी मेरी बात सुनो. प्रॉब्लम क्या है यहाँ पे? why can't we find out why can't we apply F is equal to ma? Initial velocity मालूम है, final velocity मालूम है. Definitely we can work out the distances traveled and so on, and we can. A huge problem is there. The problem is that just at the moment the block of mass m touches the spring starts to apply force on both the objects, and the spring force is a variable force. And dealing with variable forces, as you have seen before, is quite complicated. You have to use calculus, and that may get you into weird integrals. But here, I don't care. ये जो मैंने vertical black line बनाई है, so here I don't care about what happened in the duration. अगर मैं न्यूटन्स लॉज ऑफ मोशन लगाता तो मेरे को इस ड्यूरेशन में क्या हुआ एक एक मोमेंट पे कैलकुलेट करना पड़ता. लेकिन ये जो मैंने ब्लैक वर्टिकल लाइन बनाया, मैंने बोला देखो इससे पहले ये पोजीशन था और इसके बाद ये सिचुएशन, बीच में क्या हुआ है इससे मुझे कोई लेना देना नहीं. Now you may raise a doubt here कि एक मिनट तो ये path क्यों important है सर? So there are some forces which we will discuss. I don't think we'll be able to discuss today, but in the next class we'll definitely discuss. There are some forces for which the line integral comes out to be independent of path. For example, mg, right? We worked out the hard way. आप कोई भी path ले लो, work done mgh आने वाला है initial final point के बीच का vertical distance h. Some forces, for some forces, it turns out that the path does not matter. Only the initial point and final points matter. Such forces in physics are called conservative forces. Okay, I need to give you a better definition than this. I need to give you a better mathematical definition than this. But roughly speaking, a force for which the line integral is independent of path is called a conservative force. And in our syllabus, all forces are conservative except friction. So if friction is not acting, then I don't really care what happened in between. I'm only interested in the initial and the final configuration. अगर फ्रिक्शन रहता तो कहानी अलग रहती, right? अगर फ्रिक्शन रहता भी, then also I'm actually interested only in the initial and final because फ्रिक्शन हमारे लिए कांस्टेंट रहता है ना? वही मैं बोल रहा हूँ ना, फ्रिक्शन हमारे लिए कांस्टेंट रहता है. जब तक फ्रिक्शन कांस्टेंट है तब तक कोई प्रॉब्लम नहीं. फ्रिक्शन का मैग्नीट्यूड हमारे लिए कांस्टेंट रहता है. आई कैन अप्लाई वर्क एनर्जी थ्योरम फॉर फ्रिक्शन एज वेल, नो प्रॉब्लम. लेकिन अगर फ्रिक्शन है तो मेरे को पाथ की जानकारी भी जरूरी है. It is no good saying that look, there is friction but this guy of mass m went from this position to this position. अगर वो एक गोल चक्कर खा के उधर से उधर गया तो प्रॉब्लम हो जाएगी. Then the work done by friction will be something else. Okay? And we'll deal with this. We'll deal with conservative and non-conservative later. So फ्रिक्शन कहाँ है? फ्रिक्शन है ही नहीं. Basically, the purpose of this question is twofold. Number one, जब दोनों ऑब्जेक्ट्स की वेलोसिटी सेम हो जाती है, the two ends of the spring have the same velocity, then you are dealing with a condition of maximum compression, maximum elongation. Number one. Number two, if the work is calculated for the spring half kxi square minus xf square, then this thing is the work done by the spring in total on both the blocks. You cannot say that look, this is the work done by the spring on this block, this is the work done by this the spring on that block, at least for this chapter. In the next chapter when we study, you will be able to tell me the work done by friction on this block kitna hai, on that block kitna. So as far as this chapter is concerned, as far as the concept of work energy theorem is concerned, अगर एक स्प्रिंग से दो ब्लॉक कनेक्टेड है तो जो आप वर्क डन बाय स्प्रिंग निकालेंगे वो दोनों ब्लॉक के लिए. Okay, so kinetic energy initial of 2m, kinetic energy final is equal to half 2m into v naught by 3. Right, I'll be changing the slide now. So I get minus half kx square is equal to half 2m v naught by 3 whole square plus half m v naught by 3 whole square minus half m v naught square. हाफ मेरे ख्याल से हर जगह से उड़ा सकता हूँ। माइनस के एक्स स्क्वायर इज इक्वल टू कितना आएगा यहाँ पे 3m v0 स्क्वायर बाय 9 माइनस m v0 स्क्वायर which is equal to माइनस कितना 2/3 1/3 2/3 v0 स्क्वायर. So x is equal to under root of 2/3 m by k. Okay. Next question. बहुत बढ़िया पार्ट, यस। फिर से बता, एक मिनट रुक, एक मिनट, मुझे याद है। नहीं, गलत 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 है पार्ट। नहीं सोना, गलत है, गलत है। नहीं, गलत है प्रतीक्षा। फिर से ट्राई करो। ना, गलत है पार्ट। नहीं, पार्ट गलत। हाँ भाई, थीटा तो आएगा, थीटा क्यों नहीं आएगा? वेरी गुड सोहम, यस। तो let me make the diagram better. Circle, inclined plane. Good prediction. नहीं गलत है ये भाई। So block must reach here, right? Initial position, final position. Now this cannot be easier because the moment I figure out or I want to talk about the sum of work done must be work done by the earth and work done by the normal reaction. But normal reaction is just 0, so this must be equal to plus mgh. Sorry. This should just be equal to minus mgh plus 0. Nothing else. m दिया हुआ है, g मालूम है, पहले से h निकालना। h निकालने के लिए मैं क्या करूंगा कि ये इनिशियल हाइट है और ये फाइनल हाइट है। मेरे को इन दो येलो लाइंस के बीच का डिस्टेंस निकालना, because this distance is L, so I know that this distance is L sin theta. Basically, I have to figure out this distance. To figure out this distance, I realize that the inclined plane is tangential to the circle. Therefore, this must be 90 degrees. And if this is theta, this must be 90 minus theta. This must be theta. And therefore, this must be theta. And if this is the radius of the circle, if this is the radius of the circle, then this distance must be r, whereas this distance must be r cosine theta. Okay, and therefore we arrive at one of the most important expressions ever in this chapter, for this chapter, and that this distance is r minus r cos theta. Okay, literally hundreds of times, depending on how many questions you are doing, you are going to come across this r minus r cos theta. Right? I hope this is clear to everyone. So the value of h, is this distance plus this distance. ये यहाँ से यहाँ L sin theta है plus r minus r cos theta. So this will be equal to L sin theta plus r into 1 minus cosine. And therefore V naught should simply be just equal to root 2gh, which is L sin theta plus r1 minus cosine. Okay. Please remember that. So this is the purpose of this question was that if you are finding mgh hard to find, this simply means that h is what you are, h is what is difficult. So the only thing that will help you is trigonometry and geometry. आया ये सबको समझ में? More. One more. नेचुरल लेंथ 0 है। वो तो पुली भी नहीं एग्जिस्ट करना चाहिए था ना, जब उसका मास 0 था, तब तो नहीं बोला। थीटा क्या है इसमें? थीटा कहाँ से आया? हाँ, आप सही किया। That is what it is, yeah. ये इनिशियल पॉइंट है और ये फाइनल हो जाएगा, राइट? Now suppose that this is h, then this guy is equal to root of h square plus 4a square, राइट? और नेचुरल लेंथ तो स्ट्रिंग की जीरो है, which is very nice because जो भी लेंथ है that is the elongation। हाँ, ये है ना, ये m इधर आ गया ना, नीचे है ना फाइनल पॉइंट, ये है ना m इधर आया ना ये। हाँ, वर्टिकली डाउन ही तो है। So the object, the bead which was here, okay, and which can move without friction on a vertical rod, travels here, right? And basically, this is the maximum elongation. So first let's find out the work done. Summation of W is equal to work done by gravity plus work done by spring, because an elastic string is nothing but a spring, plus mgh plus half k xi square minus xf square. Is equal to mgh minus half, आई थिंक पहले किसी ने सही किया, नहीं नहीं मैं कुछ गड़बड़, पहले somebody had done it right, मैंने गलत बोल दिया, half k h square. Initial kinetic energy is equal to 0, final kinetic energy is equal to 0, so mgh minus half kh square is equal to 0. गलत किया क्या मैंने? हाँ बोल.
सर आपने स्क्वायर करके सब्ट्रैक्ट किया था वो सर फिर वो एच स्क्वायर कैसे रह गया?
हाँ
आपने स्क्वायर करके सब्ट्रैक्ट किया ना,
हाँ,
तो वो एच स्क्वायर ही कैसे रह गया?
स्क्वायर 4 स्क्वायर कैंसिल हो गया
सर एक 4ah भी तो होता. अच्छा सर मैं दूसरा देखा था.
क्या हो गया पार तेरे को? So h cancels out, one h cancels out, and I get h is equal to 2mg by k. Therefore, maximum elongation is equal to under root of 4m square g square by k square plus 4 square. ठीक है? Okay.
सर मैंने वो जो हाइपोटेन्यूस है उसको 2a प्लस एक्स लेके सॉल्व किया था, मेरे को काफ़ी अलग आ रहा है, लीनियर में आ रहा है.
नहीं, हाइपोटेन्यूज को 2a प्लस x भी अगर लेके सॉल्व किया, इलोंगेशन तो 2a प्लस x ही हो गया ना फाइनल.
यस सर, एक्स का वैल्यू बाद में मुझे 2mg बाई ए के माइनस 2mg आ रहा था.
2mg, उसको और थोड़ा वो करो, क्या बोलते हैं, सिंप्लीफाई करो.
सर इससे ज़्यादा कैसे होगा? 8mg a अपॉन ए के माइनस 2mg.
अच्छा, मुझे समझ में आया क्या किया। तो इस केस में हमारे पास आएगा mg अंडर रूट ऑफ 4a स्क्वायर माइनस ये हो जाएगा 4a स्क्वायर प्लस एक्स स्क्वायर प्लस 4ax minus 4a square. So I will get mg root x square plus 4ax. That's it. Plus half k 2a square plus minus 2a plus x whole square. mg root x square plus 4ax. यहाँ पे आएगा 2a square कैंसिल हो जाएगा, हाफ के x square half k x square plus 4x, right? This is equal to 0, है ना? ये उड़ गया, ये आएगा m square g square is equal to k square by 2 x square plus 4x. So x square plus 4x minus 2m square g square by k square is equal to 0, right? इसका solution हाँ
सर वो k स्क्वायर बाय 4 है।
हाँ
सर वो k स्क्वायर बाय 4 है।
स्क्वायर बाय 4।
हाँ सर।
सर हम लोग ने जहाँ जिस पॉइंट से स्प्रिंग जोड़ा है वॉल से, तो मैक्सिमम टेंशन हमेशा उसके डायरेक्टली डाउनवर्ड्स ही रहेगा ना?
क्या बोल रहा है? मैक्सिमम टेंशन क्या होता है?
सर मतलब थोड़ी देर के लिए मैं इसको एक स्ट्रिंग मान लूं, तो अगर मैं इसको
स्ट्रिंग है ये,
मतलब सर मतलब अगर मैं उसको अगर वो ऐसे मोशन जैसे पेंडुलम जैसा मोशन कर रहा है, तो जब वो एकदम वर्टिकली नीचे रहेगा तब से ज्यादा टेंशन रहेगा, और फिर टेंशन की वैल्यू
नीचे
तो
कहाँ आएगा जब यहाँ पे रिंग में बांधा हुआ है भाई उसको? ये तो रिंग है ना, ये रिंग में स्ट्रिंग को ऐसे बांधा हुआ है, तो ये तो केवल नीचे ही जा सकता है ना।
सर मुझे लगा वो ओके 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 मुझे लगा कि वो
गोल घूम के उधर, समझ गया तेरे को क्या समझ में आ रहा है।
ओके
नहीं वो गलत है, गलत है। हाँ। हाँ ठीक है ना, यही किया ना प्रतीक्षा। अब यहाँ पे जो है x निकाला और फिर 2a प्लस एक्स कर दिया, ये मैक्सिमम इलॉन्गेशन हो गया। हाँ बिल्कुल सही, बिल्कुल सही, एब्सोल्युटली राइट। So what we have discussed today is the application of work energy theorem. Generally, however, what is going to happen is that you are going to get in a question the application of work energy theorem combined with some other condition. Okay, you are very lucky if you get a question which is resolved only by the application of work energy theorem. That is why I have been saying that work energy theorem is just a tool, just like Newton's laws of motion. Right? So Newton's laws of motion, as we go further into physics, you will find that it is just a tool. तो हमने इलेक्ट्रोस्टैटिक्स की सारी बात कर ली, पूरा सब कुछ फोर्स निकाल दिया. जब फोर्स निकाल दिया चार्ज पार्टिकल पे, तो फिर F इज इक्वल टू ma लगाया, a निकाला, फिर वहां से मैं वेलोसिटी निकालूंगा, फिर वहां से मैं पोजीशन निकालूंगा. This is all what we have already discussed, all we have already done. So in the same way, work energy theorem is just a tool, and therefore the standalone use of work energy theorem is very rare. It is generally applied in conjunction with something else. Yeah. So in the next class, we will discuss the application of work energy theorem in conjunction with something else. So I will show you work energy theorem in conjunction with Newton's laws. I will show you work energy theorem in conjunction with circular motion. And as we move ahead in physics, you will see that work energy theorem can be used in conjunction with various other things that we will be using. Therefore, the physics that we have studied up till now, the reason why we have spent so much time on it is that I want you to be absolutely comfortable with these concepts, which are going to be applied freely once we move beyond this. Physics. Yeah, once we move beyond mechanics. Chalo, so I'll see you in the next class. ठीक है ना? अभी तो क्लास है ना, इसके बाद तो अरे अभी तक नहीं मिला, मैंने बोला तो था. एक मिनट रुको, एक मिनट. जब वो फोन उठा नहीं रहा है, अगर फोन उसका जैसे कॉल बैक आएगा, मैं ग्रुप पे डलवा दूंगा पीडीएफ. ठीक है ना? बताया था. चलो, ओके, बाय बाय.